Hey everyone, welcome back to part 2 of our door tutorial. Once again, a huge shout out to 3D Mason from Sketchfab for this model. It's super cool for this tutorial series, and we'll see more of why it's cool as we go through this video. So the first thing I want to do is set up so you can't walk through it. That I missed from the previous video, so let's get that started. So select the frame here, and on the frame you'll see a mesh collider. Set that to character collider and static, and then the same with the door. Character collider and then static. Now you can't walk through it. With the door selected, we can now talk about origin points within Neos, and so rotations with the joint component occur around the origin point. And in Neos, the origin point is the location that the gizmo shows up in. So you can see here that the translation gizmo is showing up here in the middle of the frame, in the middle of the door. And that's really well set up, and that's why I'm shouting out the author so much. Like, it's a really good model set up. Not all models will be set up like this. You may have to edit them in your 3D modeling application of choice or in Neos to achieve the goal that you want. To show how good this is, if I select the rotation gizmo here and then rotate it on the y-axis here, you'll see that the door just opens and makes sense that it's opening. It's just one rotation on one axis to get it opened. Let's undo that. We now select the handle. You'll see the same thing is set up, that the rotation axis is in the middle of the handle and is not sort of along the handle or anything like that. So if I select the rotation gizmo and rotate on the z-axis, it rotates like a normal handle. Let's undo that. We're going to start by adding the joint to the handle of the door, as that's a little bit simpler. So here on the handle in the inspector, attach component, transform, interaction, joint. Joint has a number of properties. They're very strange that wasn't set to persistent. They're very similar to other components, so persistent, update order, and enabled. They're all the same as other components. Edit mode only means the joint only operates when in edit mode. Check the permissions video for how edit mode works. Active user only is for things like avatars or guns, where there is a user which is holding or wearing an item. It means the joint can be only occurred, interacted with by the person that's holding or wearing it. Allow steal means if someone's already grabbing or interacting with the joint, that someone else can come along and then take over that interaction. Drop and disable means that when the joint is disabled up here by the enable checkbox, that it will cause a drop event where the interaction is then halted. The next properties have underscore on them, so we can skip them. Underscore usually means they're internal. Sometimes you have to touch them, but not in this case. Past that is physical. Physical means that it's a physical operation that requires interaction with your hands rather than lasers. We'll leave that off for this tutorial. Grab priorities will be a different video. You'll see grabbable has it, joint has it, slider has it. There's a lot more to talk about there. Custom grab check, I don't believe you can use in GameNet, so we'll skip over it. Past these are the actual joint properties. So here is max swing, max twist, axis, twist reference axis. These are the 4 that we're going to be using. There are ones below that to deal with snapping. They're not useful in this example, but maybe we can go over them in a subsequent video, or just try them out in game. Vibration is things like when you feel tactile feedback when interacting with the joint. We don't need to deal with that now, but check them out in game. So a joint in Neos is modeled like a ball joint. So if you think of your shoulder, which is also a ball joint, you can move it in multiple directions. So you can move your shoulder up and down, but also left and right. And so that's what the joints work here. But that isn't suitable for a handle. Like, we don't want it to move in 2 directions. We want it to move in 1 direction. And so we can achieve that by not specifying a swing and only specifying a twist. For things like levers, doors, handles, anything that's just one axis, just specify a twist. So the twist, max twist number here is the amount of twisting that's allowed, and that's measured in like the units of rotation. So you can play around by using the gizmo here and find out what a good like unit is. So here we are rotating on the blue axis here, and we can scroll up to the top of the inspector here, and we'll see that that's editing the z-axis up here. So if I rotate this down to around about 20, That looks like a handle that is all the way down, and then back to 0 looks like a handle that is not down. Let's reset the rotation so it's back to its origin point there, and so that means that 20 is a good number for our twist. So I'm going to enter 20 here, and then we'll try out the handle by clearing the gizmos. You'll see here it's rotating by 20 but on the wrong axis, and that's because our axi are not set up correctly. Let's undo that rotation, and then we need to set them up. So for the handle, the axis which our joint operates on is the z-axis by the blue here, so we need to set the axis to be the blue one, or z. So I'm going to copy this 1 across and then bring a 0 up from here. Now the twist reference axis needs to be set to a different axis from the actual axis here, so it must be different. You can usually get away of just making it the one next to it, either x or y, wherever it is, or z, just the one next to it. If that isn't the case, try around and play around a little bit. If there's an example here where we need to change this, I can always make another video. So now we have axis set to z and twist reference axis set to 1. And you'll see that the door handle goes up and down. Let me clear the gizmos so you can see that a little bit better. Up and down. And then I'll go ahead and reset that. There we go. That's it for the handles joint. So we're going to go on to the doors joint. So select the door, attach component, transform, interaction, joint. And so now here we just need to set things up again. So here the axis needs to operate around the y-axis. So we'll set up the axes. So here, y. And then, like I said, twist reference axis just needs to be something next to it, or just not the same value. So we're actually good there with the axes. They're already set up nicely. So now we just need to set twist to a value. I'm going to go ahead and set 90 for now. And you'll see that the door now opens to 90 degrees either way, which is a problem. You'll see it jumping around, but we're going to fix that. So 90 each way. One thing to note is that don't in Neos or in your games, etc., make things exactly 90 degrees or exactly this or exactly that. Doors are built by humans, and humans are organic beings, so they like things to be, they don't like things that are exact because they don't mirror what happens in reality. Like, there's no door that would stop at 90 degrees. It would be like 95 or 94. It might run into one of those door bumpers. So if you want to get a sense of realism in your world, make things not directly 90 degrees or not directly aligned or directly straight. Nothing in reality is directly straight. Nothing's really a straight line, etc. So here I'm going to actually change this to be, say, like 92, whatever, and that means that there's a little bit of give either way, so it doesn't look so rigid. Maybe 95 here. With this being set up, though, the problem is that the hinges of the doors are on this side of the door. We'll go around and take a look. Oops, I'm getting stuck on the door. So you'll see the hinges here. And that means that the door shouldn't open outwards, it should only open inwards. So we need to correct that. And the reason this is happening is because a joint allows the operation to go both ways. So if we go to the top here on rotation, we look at the y value here, you'll see it can go to negative 95, but also positive 95. And we don't want that. To do that, we need to create what's called a rotation offset. These are a little bit tricky, so bear with me. So I'm going to go ahead and reset the rotation to start with. That'll shut the door. And then we're going to go up by making a parent object here. So select door, hit the up arrow, door parent, and then we're going to rename this to be door rotation offset, just so we know what it is when we come back and look at it. Now what this means is we can apply an offset to this door that makes it operate in the way that we want, so that it only opens. So to do this, we usually take the original value that we have here, so 95, and then we divide it by 2. So I'm going to make this negative because we need to go inwards, not outwards. So if I do positive here, you'll see it opens the door. We need to make it negative. So I'm going to make this negative. We're going to be rough here. Actually, being rough is good because it means, like I said, that human effect comes in. So we're going to go for negative 46. And then we're going to go ahead and halve this again down to that same number. And now you'll see that the door doesn't come past that. So just take the number, divide it by 2, make your rotation offset approximately half, and then your max twist the other half, and then you'll see that it only opens inwards now. That was satisfying. I did it a few times. So now the only thing we need to do is make sure that when the handle is down, the door can be opened, but when the handle is up, it cannot be opened. So here's what we're going to do to do that. We're going to do a little bit of Logix. It is quite simple, so bear with me. So if we select the handle again, and like we've seen before, you'll notice that when the handle is rotating, the Z value of the slot changes. So we can pull out that slot in Logix. So get a Logix tooltip, grab the handle, secondary select, and we get the rotation. The slot interface. You'll see here the rotation is this beige color, and that means it's a quaternary. Those are kind of hard to deal with. They're advanced numbers in mathematics. You can pull one out and take a look at it. I don't know enough about them to comment. They have 4 properties in them, and they're very useful in 3D engines to make rotational maths efficient, but they're kind of hard for us to understand, and for our uses right now, they aren't really needed. So we can convert one of these to a regular type of angle, which are called Euler Angles, by using the node in Math, Rotation, Euler Angles. Oh dear. For Euler Angles, we plug this in, and now we get the X, Y, and Z out. So again, if I rotate this handle, you see the Z value is changing. So that converts the scary mathematical value into X, Y, and Z that we see in the inspector here. Let's go ahead and break up this Euler angle into its component parts. Euler angles come out as a float 3, which means there are 3 parts. You can see that by the 3 lines in the ribbon. So X, Y, and Z, and we only need to deal with the Z. So for that, we'll use operators, so Logix operators. And then we need unpack X, Y, Z. And then we pull out the Z, and we'll see we just get a single float value. So now all we need to do to check that the handle is down is compare this Z value to a known value for it being down. And we know that's around 20. But because floats are not always precise, you'll see here sometimes we had like weird decimalized stuff. So here we're 20.004. We need to make sure it's kind of a more approximate validation. So we're going to do that using the greater than or equal to operator. So if we go here to, we're still in operators, but I'll go back to the start. So operators greater than equal to. Greater than is for exact boundaries, so if it's greater than 20, it would have to be 21, 22, etc. But greater than or equal to would be 20 would be okay. So 20 would be okay, 21 would be okay, greater than or equal to. You can tell the difference by the little line at the bottom there. It's meant to resemble like a single equals being there, but also factoring in the greater than sign. So greater than or equal to, and then because of the floating numbers, they can occur both sides. So what I'm going to do for just a bit of flexibility room is we're going to say, is the Z value greater than or equal to 19? And that means we've got rid of all the floating precision errors. We've got the case covered where it's 20.004, but we've also got the case covered when it's 19.9999999, which you might see if you play around with a little bit. Let's see if I can get it. There you go. So that also covers that case where I've let go of it. It's basically at 20, but because of floating point precision, you need to use a more approximate comparison. So we'll get rid of this. And now we have a true false value for if the handle is down or not. Handle's up, handle's down. So now what we need to do is plug into the door. So we go to the door and we go to the joint, pull out the joint interface, and then plug this Boolean into enabled. And now, true, oh, that's the handle's down. So bring the handle up. Now we can't move the door. The root of the door is grabbable, so I'm just going to make that not grabbable, as that will prevent the door frame from moving when, so now we can't move the whole door, see. So I'm going to move this out of the way so we can see the handle. When the handle's down, I can open the door. When the handle's up, I can't open the door. The problem now here, though, is that if I bring the handle down, open the door, bring the handle up, I now can't shut the door, and that doesn't make sense. So the way to cover that is to do similar to this, is we go and we grab the doors value here. And then we need to basically copy this setup, but make it just a little bit more permissive. So we'll do math, rotation, Euler Angles, unpack, operators, unpack, and then what we need to now check is the y value greater than 0? Oh dear, whoops. Is the y value greater than 0? Because when we close the door, we'll see that not greater than 0 because of the offset, sorry, so 46. So when the door's shut, 46, and when the door's open, less than 46. So again here, we just need to check that the door's value is, I think it's less than this time. Yeah, it's less than. So this time we're going to use less than equal. And this time it's on the y-axis, so plug the y in. And then again here we'll do 45 here, because that covers, again, the floating point boundaries. So if the door is less than or equal to 45, then the door is already partially open, so the handle doesn't matter. We now need to combine that with this, let's get rid of this display node, with this Boolean. To do that, we need to use a logical AND. So we go up here in the operators, this to AND. And so now we need to do if the handle is down, actually we need to do OR, I'm sorry. For logical operations between Boolean values, always say it in a sentence. So if the door handle is down, or the door is already open, then let the door move. So if the door handle is down, or the door is already open, let it move. So handle is down, or door is already open. Clear this one. Plug it into enabled. And so now we should have a better time. I'm gonna go ahead and move some of this Logix out of the way. If this was your gadget, please make the Logix tidy here for a video. We're just trying to do this as abridged as possible. So now the door can be opened when the handle is down. When the handle's up, I can't open it. If the handle is down, we open it partially and then we put the handle back up again. You can still move it. But if we shut the door, the latch will enable, and now we can't open it again until we put the handle down again. All that's left to do is to pack this Logix away. So we're going to go up to the root of the door, make a new slot called Logix, set the packing route, tie this up a little bit more so that it will unpack nicely. After moving out of the way so that I could focus. That'll do, doesn't have to be perfect, but now it's more separated. Select any of the nodes, hold secondary, and they vanish, put the tool away, and we're done. We've now got a door. We can also now re-enable grabbable on the frame here, and this means you can drag that around. Let me clear that inspector. Scale it as well, so now it's more a larger door. Actually, let's put it on the ground here. Bigger. There we go. So now I can go through it. There we go. I hope that tutorial was useful. Apologies for the mix-up there. The joint component is, as I say, my least favorite component, and I frequently have issues with it. It's good, again, to see people aren't infallible, and it also shows a principle of Neos which I operate on, which is try things out, like play with the numbers. Nothing here can harm you, nothing here can blow up. The worst that can happen is your game can crash. If it does, submit a report to the team, but just play around. Like, you could adjust things here so that the door handle can't go above. Some door handles are like that. They stop at the flat point here, but this door handle will go up and down. You can do a similar offset to the other door here. Let me know what you think in the comments, and sorry for the mix-ups, but that's what you get with the joint component. I will see you again next time.